Hello and welcome back. In this video, we will see how to model a simple stress and analyze it in a software called Etabs and verify the results from the analysis. So here is a simple problem, and we are having this PDF. You can download this PDF from the link given in the description also. And here there are two supports. So there will be two reaction and at A and as well as B. At A it is a fixed support and at B it is a roller support. So first we'll open the E tabs and we'll create a new model and we'll use the metric SI units. So and the suction database, steel design code and the concrete design code does not matter because we are not going to design, we are going to only analyze. So click on OK and now it is asking for the grids. So when you look at the problem in the X or you can Y or in the Y, you can take any Y, you can model it either in the XZ plane or YZ plane, but I'm going to do it on the XZ plane. So I'm going to choose the spacing of grids in X direction as 3 and Y also let me keep it as 3 because in case if I want to do it in the Y direction I can just change it, and the total number should be 4. Anyway you can just add it over there, and the typical story height is 3 meters. Okay, this height is 3, so I'm just going to keep the number of stories as 1 and this typical story height as 3, and or you can just keep it anything. Anyway you can without using the story height also you can do it, but that are slightly a different method is there. But here I'm going to use the typical story height as 3 and bottom story height also as 3, and I'm going to click on OK. And now you can see the grids has been formed, and now I'll just go to the elevation and I'm going to model it in the XZ plane. And now you can see the XZ plane has appeared. And now before making any model, or you can do this after assigning the frames, but I'm going to do it now. I'll go to define and I'll choose the load patterns, and I'm going to use the dead load multiplier as 0, and I'm going to delete the live load. Since if you keep the dead load that is has self weight multiplier as 1, it will consider the self weight of the member. So I don't want it to consider the self weight of the member, so I'm going to make it as 0 and then click on OK. And now here we are in the XZ plane, and now I'll choose and draw the beams. And a frame section properties can be anything, it does not matter, since we are not going to design, we are going to only analyze. And okay, now again I'm going to start from here and end it here, and again I'm going to start and end it here. Okay, and now I'm going to select these joints and I'm going to click on assign restraints and I'm going to delete the restraints. That is, I'm not going to assign any support. And now I'm going to select this one, and by default when you draw it from the ground level, this one will be a fixed and this one will be also fixed. So I'm going to change this one, or if it is not assigned, select this one joint and go to assign joint restraints and I'll just click on fixed support. And after that, and I'm going to select this one and I'm going to assign the roller support. And now I'll assign the load, and at here it is 20 kilonewton, at here it is 10 kilonewton. So we'll select this, we'll go to assign joint load force. So here you need to specify the direction. Here I'm going in the z direction, that is in the negative z direction. It is minus 20, minus 20. Yeah, and I'm going to select this one and I'm going to assign it as minus 10 now. And remember one more thing. And in Etabs, it will consider this one as the not the axial members. It will consider it as a frame section. So in order to consider this one as the axial members only can take the tension and the compression. There will be no bending moment. So I'm going to select all of the members and I'm going to click on assign and I'm going to use the release or partial fixity. So I'm going to release the moments. So there will be no moment. Otherwise, there will be a moment. Axial members are not designed to take any movements. Okay, and now we'll run the analysis. It's asking us to say, okay, and here in the 3D view, you can see there is a displacement. And now I'll go to, you can also see the reactions. And now I will go to the display frame or forces. So I just choose the moments and I'll just enable the value. You can see there is no moment. And now I'll go to the axial force. And now you can see there is the axial force. When you click on moment, you see there is no moment. That means we have released the moment at the connections. You can also see there is no shear, only the axial force is there. And now we will verify the answers. Now you can see this member, you can just show the values over here, or you can just click it on this, and here you can see it is minus 23.57. Okay, we'll just remember this one. This one is AB and AB is SC. You can see that minus negative means it is compression. So minus 23.57, it is very much accurate. And here you can see this one is 0. Verify the answer. Yeah, BE is 0. And all the things which are red in color are compression and all the things which are yellow in color are in tension. So this one is in tension, it is 16.667. You can see the arrow marks over here, it is away from the frame. That means it is in tension. Okay, this one is 16.667, right? We'll verify it. That is EF. EF is 16.667 and you can see it is in tension. You can also verify the other members. Suppose I'll take this one. Suppose I take this one and this one is 13.33. Yeah, you can see FD is 13.33. And if you want, you can verify AE. AE we have verified, AF we have verified, BF. Okay, we'll verify it, a BF. A BF is 4.714 and it is compressive. So BF, yeah, you can see. Yeah, I can see it is minus 4.714. That is because it is compressive. You can see the arrows and which indicates it's a compressive force. And this is how you are going to analyze and model the simple trusses. And thank you for watching my video. Please do like and subscribe my channel for more videos like this, and comment below for any suggestions. Thank you.